This video was on general relativity. It is based on my book, Pondering Relativity, an illustrated guide for building an understanding of Einstein's relativity. My name is Doug Funky. I'm a certified professional ergonomist. My book uses human learning principles to make general relativity understandable. General relativity expands on Einstein's earlier theory, now called special relativity, and it does three things. It defines accelerations in addition to just simple relative motions. It defines how gravity works, and most importantly, it more fully integrates time with space. If you remember my earlier video on special relativity, you remember that special relativity is based on two principles. One, all motion is relative, and two, the speed of light is constant, or what scientists call speed c, or 186,000 miles per second. And when you combine these two principles, then time on moving platforms must run slow. Time on moving platforms runs slow due to the effects of special relativity. But Einstein was not satisfied with this explanation, and he spent 10 years expanding it to his more complete general theory of relativity. The problem he had with it is shown here. If you take a look at, for example, a spinning bucket, given the principles of special relativity and all motion being relative, it could be the bucket spinning, or it could be the universe spinning around the bucket. But if it were the universe spinning around the bucket, then how to explain the forces of acceleration felt on the bucket? Einstein's general theory of relativity explains how these accelerations work. Einstein also noticed that there seems to be an interaction between acceleration and gravity. In this example, the spinning bucket again, if the faster the bucket spins, the more water spills out of the bucket. And the faster the bucket spins, the more horizontally the water appears to spill out. There seems to be an interaction between acceleration and gravity. They seem to work together. And Einstein also noticed that acceleration and gravity seem the same. They feel the same. You really can't tell the difference. For example, of acceleration, for example, standing on an accelerating rocket ship or standing on Earth's surface. They feel the same. And in fact, he also noticed that they both are related to an object's mass. The more massive a rocket ship is, the more difficult it is to accelerate that rocket ship and generate those acceleration forces. And the more massive a planet is, or more massive a star is, the more gravity is generated. They seem to be equivalent. In fact, this is what he called his equivalence principle. And Einstein went a step further, and he actually showed us how you can combine acceleration with gravity by riding his bike in a curved direction, as shown here in this famous picture of him doing just that. And Einstein defined, as part of his general theory of relativity, two types of what he called frames of reference. Accelerating frames of reference, where you feel accelerations like we just discussed, for example, in a rocket ship accelerating through space or standing on Earth's surface. And he contrasted that with inertial frames of reference, where you are away from any significant sources of gravity or in free fall and are not feeling any sources of or forces of acceleration. And he said the reason for this, the reason underlying this phenomenon, is that time and space are not separate things. Time is really the fourth dimension, in addition to the three dimensions of space that we are familiar with. And when you appreciate this, and when you understand that these space and time are really combined, then you can understand how accelerations and how gravity works. In this example, on the top part of the figure, if you look at the moon orbiting around the sun, if you didn't appreciate that space and time are combined, you would think that there must be some unseen force between the Earth and the moon, keeping the moon in orbit. And in fact, this is what scientists believed, even though they didn't understand what that force was or how it worked before Einstein developed his theories. But if you appreciate that space and time are really not separate things but are combined in what Einstein called space time, and that Earth's gravity is what bends space time, and that the moon, when it orbits the Earth, is really just following the natural contours of space time as bent by the Earth. And he related this to his accelerating and inertial frames of reference. And as shown here, if in accelerating frames of reference, the rocket ship, the accelerations are really just fighting against or moving through the contours of space-time, and on Earth's surface, it is being prevented from following the natural contours of space-time that would draw you to the center of the Earth, again going against the natural contours of space-time. And in contrast to inertial frames of reference, where you are not feeling any sources of acceleration, but are just following the natural contours of space-time. This is how gravity and acceleration works. And he also related this to time. When time is experienced separately from space, time in accelerating frames of reference, like accelerating rocket ships or on Earth's surface, clocks run slow. Time runs more slowly as compared to in inertial frames of reference away from any sources of gravity or in free fall. And Einstein gave us this example to help us understand and to relate general relativity, which incorporates accelerations, and special relativity. In this example, he asked us to imagine being at the center of a spinning disk and then looking at the outer edge of the disk as it spins past and moves across your field of view. At the center of the disk, you are not feeling any accelerations and time is not slowed, but at the outer edge of the spinning disk as it moves past, just as the basis of special relativity, you have slowed time and you have experience of accelerations. This was Einstein's way of helping us see how special and general relativity can be related. And the notion that time and space are not separate things really makes sense when you think about it. You can't define a location in space without also specifying a time for being there. And in this example, as you move through a cityscape, you're moving through both space and time. Here shown with time on the vertical axis. As you move through the cityscape, you're moving through both space and time. When you get stuck at a red light and you stop moving through the space dimensions, you're moving through time alone, but then when you begin to move again when the light turns green, you are again moving through space and time. But the connection is deeper than that. When you look at space alone, and this is a beautiful picture of the Niagara River, but it's pretty moribund, pretty static. It doesn't have much meaning other than being a pretty picture without time. But when you add time, then this picture comes alive, it gains meaning, it gains essence. Time gives space meaning and essence. Time gives the universe both meaning and essence. So, to summarize, general relativity, it does three things. It defines how accelerations work beyond just simple relative motions that were defined and described by special relativity. And it is movement relative to space time that defines acceleration. It's what distinguishes between inertial and accelerating frames of reference. And it is an object's mass that determines the amount of acceleration that's achievable. It also defines how gravity works. It defines why gravity and accelerations are really equivalent phenomena. It shows how gravity works by bending space time. And similar to accelerations, it's an object's mass or a planet or a star's mass that determines the amount of gravity that gets generated, really the amount of space time bending that occurs. That's how gravity works. But most importantly, general relativity more completely integrates time with space in what Einstein called space time. And time adds essence to space, it adds meaning to space. Time adds meaning to the universe. I thank you for listening to my video. Again, it is based on my book, Pondering Relativity, an illustrated guide for building an understanding of Einstein's relativity. I hope you get a copy of my book. It has illustrations throughout the book. You can see how relativity works. It's available at Amazon.com, or you can visit my website, ponderingrelativity.com. Thank you.